Namaskar. I'm Harpreet Kaur and I welcome you all to our live and interactive session. You are watching us on PME Vidya channel number 6 and also on our YouTube handle NCERT Official. This session is meant for us students of class 6 and the topic we are taking up is Prime Time Part 3. Part 3 means today we will be focusing on the third part of this chapter. We have already covered 2. In case you have questions related to this topic, you can definitely give us a call and speak to our expert. Our phone number is 8800440559. Our email ID is tth.class6@ciet.nic.in and on our YouTube handle NCERT Official, you can send us your questions, suggestions and feedback. For this session, we are once again joined by our expert, Ms. Swarn Lata Sharma. Ma'am is a President Awardee teacher and also currently working in Mother Mary School. Ma'am, namaskar. Once again, very warm welcome to you.
Thank you, Harpreet. Hello, viewers.
And today we have the privilege of learning another beautiful, amazing concept from you in the session. And for this session, we are joined by our Indian Sign Language interpreter, Mr. Dev, who will be helping us express this journey in ISL. Dev, namaskar and very warm welcome to you too. Ma'am, this is the third part of this chapter, which means we have already covered 2 parts of the same. So please tell us what all we have studied in those 2 parts and what are you making us learn today?
Sure. In the first session, children played game about idli vada and they learnt about multiples and factors. And in the second section, we discussed about the prime numbers, composite numbers, how to find out prime numbers from 1 to 100. They learnt about that, and in this session, they will study about co-prime numbers. They will learn about prime factorization, which is very important concept.
Right. Okay. So, ma'am, let's understand what is prime factorization then.
Yeah, we will understand. First, let me discuss about the learning outcomes, Harpreet.
Sure.
Prime factorization, in this learning outcomes, children are going to learn about it. The students will understand how to break down a number into its prime factors, Harpreet.
Okay.
Okay. Which is very crucial for simplifying numbers and solving problems involving LCM and HCF. That is least common multiple and highest common factor. Okay. And they will also study about co-prime numbers, Harpreet. Students learn to identify co-prime numbers, numbers with no common factors other than 1.
Ma'am, I used to get really confused when I was a kid, prime number, composite number, odd, even. So today I think I'll be brushing up my skills of mathematics.
Yes, you will understand. We'll be doing many questions and many activities. I hope that concepts will become clear.
Absolutely.
Okay. Here we will discuss some questions, children. We were discussing in the previous session. Twin primes are pairs of primes having a difference of 2. For example, 3 and 5 are twin primes. You understood 3 and 5 both are prime numbers and the difference between 3 and 5 is 2.
Yeah.
So, they are named as twin primes.
Okay.
So, are 17 and 19. Find the other twin primes, children, between 1 and 100.
Wow.
Okay. So, 3 and 5, 5 and 7, 11 and 13, 17 and 19, 29 and 31, 41 and 43, 59, 61 and 71, 73 are the twin primes lying between 1 and 100. Okay. You can check each of these pairs. You will find the difference between the prime numbers is 2. Therefore, they are named as twin primes. Okay. Now come to another question which is very interesting. You are supposed to identify whether each statement is a true or a false statement, and you need to explain also, Harpreet.
Right.
Okay. There is no prime number whose units digit is 4. Okay. Why? This is a true statement because any number ending in 4 is obviously divisible by 2.
Divisible by 2, yes.
Okay. And being divisible by 2 means it is not a prime number.
It's a composite number.
Yes, understood. So, you have understood composite number and prime number in the beginning itself.
Yes.
Now, come to a product of primes can also be a prime. It is false. Because product of 2 or more primes will always have more than 2 divisors.
Yeah.
It becomes composite. Okay, therefore the statement is false, children.
Like 3 into 5, 15, divisible by 3 and 5 both.
Yes, good. prime numbers do not have any factors. This is again false, children, because prime numbers have exactly two factors, one and the number itself.
Of course.
This is by the definition itself.
Yeah.
Prime number has two factors, one and the number itself.
Right.
Okay. So, the statement this is false. Now, let us come to the next statement. All even numbers are composite numbers. This is again false, because 2 is such a even number and a prime number 2. 2 in fact is the only number on the earth which is even
And a
as
prime
well as
number.
prime. Okay, children. Now, come to the next statement. 2 is prime and so is the next number 3. For every other prime, the next number is composite. The statement is true, children, because for all primes greater than 2, the next number is an even, and all even numbers greater than 2 are composite. Quite obvious, right?
Right.
You can check the numbers, you will find that they are composite numbers. They have more than 2 factors. Come to the next question. Which of the following numbers is the product of exactly 3 distinct prime numbers? Okay, understand the question very carefully. 3 distinct means different.
Okay.
Okay. Now, let us see 45. What are the factors? 3 into 3 into 5. There are 3 factors, but they are not distinct, Harpreet.
Yeah.
3
Because
is
3 is being repeated.
Yes. Come to 60. 2 into 2 into 3 into 5.
Again, no.
We have 3 factors, but 2 is a repetition here.
Yes.
Okay, so 4 factors we have here. What about 91? 7 into 13.
2 numbers.
2
but we need
numbers.
3.
Okay. Now come to 105, Harpreet. 3 5s are 15, 15 7s are 105.
I think this is the answer.
Yes, you are right. 3, 5 and 7 all are different. So, they are distinct prime numbers. So, 105 has 3 factors, 3, 5 and 7, and they are distinct prime numbers. What about 330? 2 into 3 into 5 into 11.
Distinct
We have
prime
4.
numbers, but 4 numbers.
Yes, therefore, the number 105 is the product of exactly 3 distinct prime numbers, 3, 5 and 7.
Okay.
I hope it is clear, children.
Yes.
Now, how many 3-digit prime numbers can you make using each of 2, 4 and 5 ones? Okay. Numbers formed by using digits 2, 4 and 5 ones can be 2, 4, 5, 2, 5, 4, right? 4, 2, 5, 4, 5, 2. What about 5, 2, 4 and 5, 4, 2? Understood?
Yes.
I think these 6 numbers are possible. 245 is divisible by 5. So, obviously, this is not prime.
Yes.
What about 254?
Divisible by 2, of course.
Yes, so it is not prime. What about 425?
Divisible by 5.
5, so it is not prime. 452, it is divisible by 2,
Yeah.
therefore it is not prime, it is ending in 2, right?
Yes.
Therefore, it is divisible by 2. What about 524?
Again 4.
It is divisible by 2,
Yeah.
yes, it is not prime. 542, it is divisible by 2, so again it is not prime.
Yeah.
So, therefore, children, there are no 3-digit prime numbers that can be made using digits 2, 4 and 5 once. Alright?
Yes.
Okay. Now come to the next interesting question. Observe that 3 is a prime number and 2 into 3 plus 1 is equal to 7 is also a prime number, isn't
Yeah.
it?
Yes.
2 3s are 6, 6 plus 1 is 7. Are there other primes for which doubling and adding 1 gives another prime? Find at least 5 such examples. There are many more, of course, but 5 you are supposed to list out. So, for prime numbers 5, let us double it. 2 5s are 10.
10.
10 plus 1 gives me
11.
It's prime. What about 11? 11 2s are 22 plus 1 23, again it is prime. 23 into 2 gives me 46 plus 1 47, it is again prime. What about 2 into 29? It is 58, 58 plus 1 gives me 59, which is again prime. What about prime number 41? 2 into 41 gives me 82, 82 plus 1 is 83, which is a prime number.
Yeah.
Therefore, 5, 11, 23, 29
41.
and 41 are other such prime numbers. Okay.
Yes.
So, let us revise prime numbers. The numbers that have only two factors, Harpreet, they are known as prime numbers or primes.
Yeah.
For example, 2, 3, 5, 7, 11, 13, 17, 19 and so on.
Divisible by 1 and the number itself.
Very good. What are composite numbers? The numbers that have more than two factors, Harpreet, they are known as composite numbers. For example, 4. 2 into 2 into 1.
4. 1, 2
And 4.
Yeah.
Yes. And 6, 8, 9, 10, 12, 14, 15, 16, 18, 20. All these are composite numbers.
More than two factors.
Very good. We had done in the previous session, children, if you remember, sieve of Eratosthenes, and we learnt how to find out all the prime numbers between 1 to 100.
Okay.
Can you see the encircled numbers, Harpreet?
Yes.
In green.
2, 3, 5,
yes,
7.
these are prime numbers. Okay. This we have to keep in mind for today's session. We will be listing out these prime numbers. Now come to prime factorization. Prime factorization is of fundamental importance, children, in the study of numbers. A number can be written as the product of two of its factors. These factors may be prime or composite.
Right.
If composite, the factors can be split up further till they are all prime numbers. Since a composite number can be expressed as a product of prime numbers, we write 18 as 3 into 6 and say 18 has been factorized. This is one of the factorization of 18. The others are 18 can also be factorized as 3 into 6 is equal to 3 into 2 into 3 and 18 is equal to 2 into 9, that again can be written as 2 into 3 into 3. In both the cases we arrive at 2 into 3 into 3, isn't it? So, in this factorization 2 and 3 are prime numbers. Okay? Such a factorization of a number is called prime factorization.
Okay.
Okay? Now, prime numbers are the building blocks of all whole numbers, children. Starting from the time of the Greek civilization more than 2000 years ago to this day, mathematicians are still struggling to uncover their secrets.
Oh.
Is there a largest prime number, or does the list of prime numbers go on without an end? Does it continue? The fun fact here is the largest prime number that anyone has written down is so large that it would take around 6,500 pages to write it. So, they could only write it on a computer.
But can we? Because numbers are infinite. Can we really find the largest prime number?
Yes.
Okay, still possible. Okay.
Yes. Now come to co-prime numbers, children. Two numbers are said to be co-prime to each other if they have no common factor other than 1.
Oh.
For example, as 15 and 39, they have 3 as a common factor.
Yes.
They are not co-prime. But what about 4 and 9? They are co-prime as they have 1 as their common factor.
Okay.
Right? So, let us see here we have co-prime numbers.
Right.
12 and 35, children. Okay. Factors of 12, 1, 2, 3, 4, 6 and 12. These are factors, Harpreet, of 12.
Right.
Let us list out factors of 35. They are 1, 5, 7 and 35.
Right.
What is common? Can you find?
Yes, it's
only
one.
1 is common, right? So, 1 is a common factor of 12 and 35. So, they are co-prime numbers. I hope it is clear?
Yes, ma'am.
Okay. Now, what about 15 and 37, Harpreet? Factors of 15 are 1, 3, 5 and 15.
Yes.
And factors of 37 are 1 and 37.
Yeah.
So, they are co-prime numbers. Let us look into 2 more examples here.
Okay, ma'am.
Sorry. Are they co-prime numbers 17 and 85? Factors of 17 are 1 and 17. Factors of 85 are 1, 5, 17 and 85.
No, they are not co-prime.
Yes, they have 1 and 17 as common factors.
Yeah.
So, they are not co-primes. Okay. What about 215 and 415?
Okay.
What are the factors of 215, children? 1, 5, 43, 215. And what are the factors of 415, children? 1, 5, 83, 415, number itself. Okay. So, here also we have 1 and 5 as common factors. So, they are not
Co-prime
co-primes.
numbers.
I hope the concept is clear now.
Absolutely.
Okay. Now, let us discuss another fact here about how to find out a factor tree, how to draw a factor tree. Make factor tree of 36 to write the prime factorization in different ways. The interesting part here is, Harpreet, I will take this 36 and I will try to find out its factors. What are the factors?
2 and 18.
2 and 18. 18 2s are 36. 18 can be factorized as 2 and 9.
Yes.
2 into 9 is 18. How 9 can be broken into two factors?
3 by 3.
3 by 3. So, what are the factors of 36 here? 2 into 2 into 3 into 3. Agreed?
Yes.
Okay, we have here. What about this 36? If I factor this way, 3 into 12 is also 36.
Yes.
Can I break this 12 as 3 into 4?
3 into 4.
Okay. What are the factors of 4 here?
2 by 2.
2 and 2. Okay. So, what are the factors? 3 into 3 into 2 into 2. Are they same?
Yes.
Okay. Let me try here. 36 can be broken as 4 9s are 36.
Yes.
I can again break this 4 as 2 into 2.
Yes.
And 9 as 3 into 3.
True.
Can I find again the same factors appearing?
Absolutely.
Okay. 2 into 2 into 3 into 3.
And if we do 6 into 6 for 36?
Yeah. Again you will have same. See, if I do take 36 and 6 into 6.
Yeah. And then 2 into 3, 2 into
Here
3.
we have 2 into 3 and again 2 into 3. So, whichever way we do, children, every composite number can be factorized as product of primes. Okay, irrespective of the order in which they appear. Okay, they may occur in the beginning 2 into 2 into 3 into 3, or 3 into 3 into 2 into 2, or 2 into 2 into 3 into 3, or 2 into 3 into 2 into 3.
That's very interesting.
Interesting, right? So, these are the ways we prepare the factor trees. Now, let us solve a critical thinking question.
Tree.
Okay? Factor tree. Complete the factor tree and solve the questions. We have a question here: 120, 24 and x, y and 8, z and 4 and z and z.
Okay.
Now, let us start reverse. What are the factors of 4?
2 into 2.
Okay. Let me write down 2 into 2. 4 is to be multiplied by what number to get 8?
2. 4 into 2.
8 is to be multiplied by
3.
to get 24. 24 is to be multiplied by what number to get 125?
Okay.
Okay. That means I am able to find out x is 5 and what is the value of y?
3.
What is the value of z?
2.
2. Now, I am supposed to find out the value of x plus y plus z. What is x?
5.
What is y?
3.
3
And z
plus
is
z.
2.
Z is 2. So, 5 plus 3 is 8. 8 plus 2 is
10.
10. Right? This way we solve. Find the value of x into y into z. Let us multiply. X is how much? 5 into
3
y is 3
into 2.
into 2. 5 into 3 is 15. 15 2s are
30.
This way we can solve.
Okay.
Alright. We can do either way. I can start factorizing here also. I can divide 120 by 24 to find out this 5, and then I can do from top to bottom as well, and it becomes easy when I go from down to top.
Right.
Okay. Alright. Then come to our next question. Find the prime factorizations of the following numbers.
Okay.
64, 104, 105, 243, 320, 141, 1728, 729, 1024, 1331 and 1000. I have done it for you, children. This is a question from your textbook. It is Ganit Prakash for class 6. 64 can be factorized as 2 into 2 into 2 into 2 into 2 into 2 6 times. So, I can write it as 2 to the power 6.
Yes.
104 can be factorized as 2 into 2 into 2 into 13. So, I can write it as 2 cube into 13. What about 105? 3 into 5 into 7. 243 can be factorized as 3 5 times. So, 3 to the power 5. What about 320? I can write this as 2 to the power 6 into 5. What about 141 children? These are little challenging. You have to try out. We have 3 into 47. We get only 2 factors here. Now come to 1728. You can factorize for yourself and check whether I have done it correctly. 2 to the power 6 into 3 to the power 3. What about 729? I can write it as 3 to the power 4. What about 1024? I have to multiply 2 how many times, Harpreet? 10 times.
Wow.
So, 2 to the power 10 gives me 1024 children. What about 1331? 11 into 11 into 11 will give me 1331.
11
so, 11 cube. What about 1000? Very simple. I will in fact break it as 10 into 10 into 10 and then write down 2 into 5 into 2 into 5 into 2 into 5. So, 2 3 times and 5 also 3 times. 2 to the power 3 into 5 to the power 3. Okay. Now, the next question here is the prime factorization of a number has 1 2, 2 3s and 1 11. What is the number? On multiplying the prime factors, what do we get? 2 into 3 into 3 into 11 gives me 198 children. So, the number is 198. Find 3 prime numbers all less than 30 whose product is 1955.
It's a very tricky number.
Yes, prime factors are 5 into 17 into 19. Okay, you can try this. Find prime factorization of these numbers without multiplying first. If I multiply, Harpreet, I will get a big number.
Yeah.
Instead of that, I should try to break down 56 into factors. 8 into 7, 8 can be written as 2 into 2 into 2 into 7 and 25 can be broken as 5 into 5. So, the answer will be 2 to the power 3 into 5 to the power 2 into 7. Okay. 7 to the power 1, I need not write down, 1 is usually not written.
Yes.
108 into 75 can be factorized as 2 to the power 2, 3 to the power 4 and 5 to the power 2 children. Okay. What about 1000 into 81? I can write this as 2 to the power 3 into 5 to the power 2 into 3 to the power 4. What is the smallest number whose prime factorization has 3 different prime numbers? What are 3 different prime numbers? And the challenge is it should be smallest number, children. So, 2, 3 and 5. If I multiply, 2 5s are 10, 10 3s are 30. Okay. 4 different prime numbers. I will include 7 also now. 2 into 3 into 5 into 7 gives me 210. I hope it is very easy and clear for you.
Yes.
Okay, thank you. I think you have understood this.
Yes, we all understood it thoroughly, and the way you explain factorization and prime and composite, I think it is also very interesting and it's kind of fun. You can solve the maths puzzles with your friends, finding the smallest prime number and the largest prime number with the smallest one having different factors.
Yes.
So that's quite interesting, ma'am.
Now, Harpreet, can you tell me what is the largest composite number which is a single digit?
Largest composite number, single digit. Of course, it's 8.
9.
9. Oh, yeah, it's 3 into 3.
Okay.
Yes,
like this, children, you can play yourself in the classroom. Okay.
Absolutely. And you can play and then you can correct your mistakes. And of course, this is how you learn concepts. And learning by doing is something that we try to strive for.
Exactly.
So, ma'am, thank you so much for your time and contribution to the session.
Thank you so much.
And I must thank our ISL interpreter, Mr. Dev, also for his contribution. Thank you so much, Dev. And now let me tell you about what's coming next. Here is the program schedule. We are through with our session of mathematics, and now we have next session of our online training where the topic is going to be Alekh Lekhan or script writing. After that, we will end the day with our session Sahyog where the topic is going to be building self-worth and developing a healthy sense of self. We request you to kindly stay tuned and participate in the session with your questions, suggestions and feedback. I thank my entire team for making this session a success. With this, it's a wrap. This is me, Harpreet Kaur, leaving you, but I'll join you soon. Namaskar.